good morning, according to local time, and good afternoon, according to Munich time. This is where I'm from. My name is Ralf Waldvogel, excellent pronunciation. And I would like to talk to you about how to build a washing machine. But I'm a very curious guy. I have 3 questions I would like to ask you first. First one is, who is involved in some kind of enterprise IT? Okay, and if you're not sure whether you're in an enterprise IT or not, you're definitely not. You know when you're in enterprise IT. Second one is, who is planning to introduce some kind of deep learning in its organization? Yeah, this is why you're here, I think. And last question is, who has already deployed some kind of deep learning and put it into production and used it? Oh, maybe we've made the same experiences. So let me first talk a little bit about enterprise IT. I'm consulting IT companies, enterprise departments for 21 years now. And enterprise IT breaks down, for me, often to top-down decision-making. It's often projects, not products. And with that goes along static metrics-like organizations, where developers have, say, 10 to 15 projects at one time that are working on. And IT is a cost factor in enterprise IT. It is not an enabler. It is not used to build new products, to try new ideas. It's basically about lowering the costs of operating a system. And it feels often like a big container ship with a huge turning radius. And it's very hard to steer it and give it a new impulse. And in such an environment, it is really hard to introduce new technology and to innovate. And if we're looking at deep learning is right at the verge of being on the, say, innovator side to the early adopter side. It's really an innovative way to do new things. And the product I would like to show you today is trying to do this, innovate and introduce new technology in an enterprise environment. It's deep learning, actually. I'm part of the product team since the beginning of 2016 as an agile coach for technology architecture and development. So yeah, part of my job is introducing new technology. And it's done for a customer, Colenet. It's Allianz Germany. If you don't know Allianz, it's the 21st largest company in the world. So definitely enterprise IT. And with that product, we'd like to build a better CRM system, a customer relationship management tool for their agents. A customer has many ways to interact with Allianz, the web, the phone, and agents. And I'm pretty sure everybody of you knows an insurance agent. So agents are best at consulting with customers and customer interactions, like finding the best insurance package for a personalized situation, a personalized environment. And consulting is their core business capability. Consulting with customers is what they add to Allianz as business value. And if this is their core capability, what do you think does the daily life of an agent look like? Allianz made an extensive user experience research in 2015. And remember, consulting with customers is the core business capability. And that user experience research showed that 50% of the time they spend on non-consultancy activities. 50% of the time they don't spend on what they are best, on what they add as business value to Allianz. And that they are not sitting around sipping coffee, like I do with water. They are doing menial tasks like data entry, checking with headquarters where a claim is, and printing out stuff. And the user experience showed one more thing, which is not surprisingly, that some agents perform better than others. Let's call them for a second A, B, and C agent. With the A agents being roughly 10 to 20%, and they are adding roughly 40 to 55% of the business value of all agents. So yeah, they are the top agents. Top agents spend more time consulting with customers with the right topics and at the right time. So it's 2 points here. Doing more consultancy and consulting the right customers, the right time, the right topics. And of course, they spend less time doing menial tasks, like I said, data entry. Now imagine for 1 second, what will happen if all agents, A, B, and C agents, were top agents? So, question is, and we would like to have every agent to be a top agent. Question is, how can we empower them to become top agents? The same question was asked by Allianz Germany. The microphone's okay? Yeah. And to answer that question, Allianz put together a product team, cross-functional domain experts, business analysts, user experience designers, IT guys like me, and just to answer the question, how can we build a better working place for all agents? Like giving something to the agents that they can work with that empowers them to become top agents. And it breaks down to finding a personal assistant, like like a secretary to you. And to build a better working place and to empower all the agents, we have to learn from the best. And build, as I said, a personal assistant for every agent. And the question remains, we want to learn from the best. How can we learn from the best? Well, a traditional approach I've seen often is in enterprise IT, let's hire lots of business analysts. Put them together, let them shadow the top agents, writing concepts, writing the rules, implement them, handing over to quality assurance, and then put it into production. And as you can imagine, this would take quite a long time, too long for us. And it would be too static because by the time when such a system goes into production, the world in which an agent acts has changed, and the top agents are adapting to the change. So we said, no, we don't want to we want to follow this approach. Now for something a little bit different, completely different, I wouldn't say, on 9th of November 2015, 6:30 p.m. It's really a coincidence that Heise, one of the co-sponsors of this event, announced on their news ticker that Google is open sourcing TensorFlow. And this is good news for us as a product team, because we are relying on TensorFlow as a tool, and it's open source, so we can really start very quickly without spending too much money, with the ability to read the code and sometimes to modify the code. And one more thing. You remember the keynote, the manifolds, or the mathematical constructs, and the mentioning of GPUs and lots of computational power. 3D gaming has advanced in the last 10 years tremendously. And with these advances in 3D gaming, we get a drop in the price per flops. Flops is basically floating point operations per second. So how many additions and multiplications can we do in 1 second? And 1 gigaflop is basically, in English terms, 1 billion additions, multiplications per second. And don't look at the figures, they're not really interesting. Just look at how it drops. And with that drop, we get computational power at our hands. So that we have today 12 teraflops for less than 1,000 euros. It's in English terms 12 quadrillion floating points operation per second for less than 1,000 euro. And it's gaming. And if you like to start small, like we did, You put together a real nice and decent gaming PC for less than 3,000 euros, put it under your desk, and you can start deep learning. And that's actually our first deep learning machine we acquired. It's less than 3,000 euros. We trained the nets on nets, I'm talking about later on that machine. So how does this come all together, like building a personal assistant, learning from the best, empowering all the top agents, TensorFlow, and GPUs being very, very cheap. Ian Goodfellow put it really nicely in his really excellent book, Deep Learning. Machine learning allows us to tackle tasks that are too difficult to solve with fixed programs written and designed by human beings. And I'm not talking about, like in the keynote, simulating the whole human brain. I'm talking about very specific tasks, very specific tasks. And we decided from the product team that we would like to answer the question on how to learn from the best in discovering the patterns with deep learning. What makes a top agent a top agent? How is he differently acting from a not-so-top agent? And we let the machine discover the patterns. And it basically falls back, you remember also the keynote, the manifolds, finding all the manifolds. And when we introduced this idea, let the machine discover the patterns. No, we don't write rules. No, we don't use business analysts for finding the rules and writing conceptions. One reaction was, this cannot work. Well, of course it does work. Google and Apple and whoever shows us daily that it works. And the other reaction was, also remembering the keynote, wow, really, we can do everything, mostly business side. No, we can't. We can't do everything with deep learning. This is because what we have right now in deep learning is the equivalence of a frog brain. So we can't basically nothing do more than a frog can do. And we can do amazing things with the equivalence of a frog brain. And one more thing showed up when we introduced the idea to let the machine discover the patterns. It was a fundamental misunderstanding. Nobody was really used in this organization to talk about deep learning. What is deep learning? So some guys like me were talking mathematics, loss functions, stochastic SGD. Others were talking big data, others were talking Watson. And we had no way to communicate. We had no way to find a common goal. And we had to align our ideas. And we literally sat, I think, for 1 week there, discussing that way. Really no way to get on common grounds. Till one day, Daniel is sitting up there. Our product owner came up with, hearing all the discussions, hey, this sounds to me like a washing machine. Like, hey, we put in the data, we have all the feedback loops we need, we have to train, we have to turn over and over and over the data. And we get out the rules, nicely cleaned. So it's, we found the metaphor, the washing machine. And that picture, that image, helped us in communicating with each other. And for me as a technician, it's definitely a leaky abstraction, but it works in communicating. Communicating, finding a way to talk with business on, hey, how do we get started? What's our goal? What do we like to do? And so everybody had a common understanding of the washing machine, of the idea, what we try to achieve and how to achieve with deep learning. And this created coherence. And that coherence, we were able to communicate not within our product team. What is the idea behind deep learning? How can we use it? But we were able to communicate it within the organization. And remember, Allianz is a real big organization. And it takes time to proliferate such an idea, that the guys that do the funding catch up with the idea. And the washing machine literally helped us in communicating it. So we pitched it, and we got funded. So we have an idea, we can communicate it, we have the funding. Productivity, and Henrik Nieberg from Spotify put it really nicely. Productivity is equals effort. Yeah, we have to do something, we have to code, we have to put something into production. Times competence, we need to know what we are doing. The preferable, the more, the better. We need an environment where we can build such a system, where we can build the first time in a big organization a deep learning system, and we need to be motivated. Motivation matters to him more, but doesn't matter. So we are willing to put in effort. We got the funding, we got the competence, we are motivated, and we were lacking the environment. So the question was, where do we start the development of the deep learning system? We were lucky because Allianz Germany founded in April 2016 what they call the Agile Training Center. And it's one of the Allianz's challenges, answers to the digital challenge. And you remember the container ship, the big container ship? It's breaking it down to little small boats, taking every container one at a time and transfer it to a little boat. And this swarm of boats are building up the new software that Allianz is building. And every boat literally translates to a product team, not a project, but a product team. And all the product teams, the boats, are highly autonomous. We can decide on our boat how we run it, with which tools we run it. We use TensorFlow, others might use MXNet or Caffe or Torch7 or whatever. And we are highly aligned in that we are heading towards one goal. Yeah, we are co-located in an offsite. We're working day to day on a we're not working face to face with each other. And the Agile Training Center is one more thing. It's a lean startup. So every product is a lean startup. And it has to build a minimal viable product, and to prove that deep learning, in our case, a personal assistant, can help, in our case, the agents to perform better within 3 months, from the idea to putting it into production to really run it. Yeah, we use Scrum Fun, it's not so interesting. And we're end-to-end responsible. It's not like having a great idea, like, hey, cool, let's use deep learning. No, we have to put it into production. We have to solve everything that is needed to run the system, to train it, to get the data, and whatever. All in all, it's a very agile-friendly environment. And yeah, just an impression. So we've got the right people, the right mindset, the right environment, and we got the funding of the MVP. Let's bring the idea to life. Imagine just for one moment, how would a personal assistant would look like to you? Yeah, I'm quite sure you have many ideas, as we had, and the complete personal assistant would have been too big to complete, to build within 3 months. So we had to find something that we can deliver, that we can prove deep learning works, deep learning helps. Within 3 months, basically finding a minimal viable product. And we decided that it might be a good idea to build a filter for every agent and to find the most important customer messages for him. And if you look at your emails, if your inbox, you get tens to hundreds of emails per day. And if you're using Gmail, Gmail flags and learns what is important to you and what is not. And we try to flag what is the most important message for you in the day. So we flag them, mark them, all messages, whether this is a consulting opportunity or a service. Consulting opportunities is the core capability of all the Allianz agents. So we flag these opportunities because this is the business value they add. We mark them others for services. This is something that you can delegate. You don't have to delegate it, but you can delegate it. As you can imagine, there's a huge diversity in content that comes in, all kind of messages we have to classify. And it's a huge diversity in length. This is much more of a technical detail if you're coming to neural networks, deep learning. And we have stable words. Again, a technical detail. We are lucky because we are just right at the moment marking and classifying electronically filed messages. We are not using OCR, optical character recognition, and we have scans from letters, which is another a challenge, I would say, in reconstructing the words. And there are techniques like character-to-word embeddings with nice papers. But we have stable words for now. So let's build the classifier. Building a classifier is basically very easy. We have a build, measure, learn loop. We start with the learning. We think of a network that we think of a network that can classify, or which we think is good at classifying messages. And then we build the network. We train it, we put in the data, and then we measure it. How well does it perform? And if we're satisfied with the accuracy in our case, then we say, okay, we finished that. Otherwise, we go to the learn. We tweak with the parameters, we try other networks, and learn again. And so we have a reiterating loop, build, measure, learn until you're satisfied. And you're doing this the first time you're going into a classification literally thousands of times. So I have it really small. But to get that loop kickstarted, we need something. We need labeled samples. And remember the cats, where a network is just scanning all the nice YouTube videos and learns what is a cat. We do something totally differently. It's called supervised learning. And for supervised learning, you need labeled samples. It has to do something with how the network learns. So you show a network a sample, a message. The network thinks, calculates a little bit of stuff, and then he says, to me, this message is an opportunity. And then you show that. And then you show the network the ground truth, like, hey, this is not an opportunity, this is a service. And you go over and over again. So you need samples. You need to look. You have to have messages that are marked, and then you train the network. And labeling the samples is a time-consuming task. Someone has to sit down and think, have to read the message, and has to classify it. Yeah, this is a service, this is an opportunity, and so on. This is really, really time-consuming. And after, I think, 2 weeks, we ended up with 4,000 labeled samples and 3 classes. So we don't only have opportunities and services. We have something that even the domain experts can't decide whether this is the one or the other, and it's called a noun. There's a rule of thumb that states you need around about 5,000 labeled samples per class. We've got 3 classes, so we need around about 50,000 labeled samples. 4,000 is less than 50,000. And we asked our business guys, hey, could you please label 3 times more messages for us? And they said, no, we can't. So we had to find another solution. And, well, we applied some techniques to our models. I'll show you just for one moment, won't go into detail. But basically, it's a multi-layered recurrent network with LSTM size, with varying sequence length, and word embeddings. That's the stable words I'm talking of. And we applied many dropout layers for the more technical guys won't go into detail too. We apply many dropout layers with a huge variation in the dropout rate, and we use pre-trained embeddings. And maybe there are some sessions later on where you can hands-on try this with TensorFlow. So you could get an impression what it takes. We achieve with this 80% accuracy. which is a nice starting point for us. We're not satisfied, of course, but yeah, it's a nice starting point. One thing we have to consider in training these networks is data privacy and information security. This is because we train on real-world messages. We don't have a generator that generates something for us. We take real-world messages that come in, and we classify them. And we train on these real-world messages. And as you can imagine, these customer messages can contain all sorts of confidential information. Just think yourself what you would write your insurance agent. And in Germany, at least in Germany, I don't know about other countries, law and compliance rules demand that only a few designated employees handle these messages in clear text. Really, only a few specially trained employees. I'm not one of these, but I would like to train. I would like to build the networks. I would like to try to go into the build, measure, learn loop. And that's currently a research topic. I deliberately choose one of the papers that might help. It's not the point that this paper might help. It's the point about how the papers are written. It's a very technical paper, and you have to understand what's written in that. You have to understand what deep learning means, all the mathematical models, so that you can decide, is this a solution that we can apply so that we don't violate with we don't violate with the law and compliance rules. And so it's not only about training your development team so that they can understand deep learning and build their own networks and train them. You have in an enterprise IT to train the surrounding organization as well so that they can reason about mathematical papers like that. Because an information security officer has to approve this solution complies. We found another solution. We didn't apply this because the people aren't used to it yet. It's just a matter of training time. So we decided to find another solution. I would like to show it just briefly. And we have to look at how text classification works. And text classification works like this. Take the raw text, the incoming message, break it into tokens, get rid of everything that you're not interested in. Then assign each token a number, and then get a sequence of numbers. And then you learn with that sequence number. And as I told you, I'm the one who likes to build the networks, to generate the networks, to train them, to tweak them. But I can't handle the clear text. So again, we take the message, then we tokenize it, get rid of all the stuff we're not interested in, normalize it, and then we get tokens. For the sequence, we get a sequence of tokens. And as you can see, there are many tokens, and we've got two tokens, despite the three normally used tokens like no operation, unknown, and end of sequence. We've got two more special tokens, it's number and it's email. We're not interested in the real numbers, on the real figures that are written in the email. We are just interested in, hey, here's a number in that sequence of tokens. And we're not interested in, this is the email of the customer. We are just interested in, here's an email in the sequence of tokens. Then you use a dictionary, and the dictionary is pre-built. You go over millions of messages, find the most common words, the most common tokens, and assign each token a number. And then you take the dictionary to translate the tokens into numbers, into vectors. And from a compliance perspective, raw text is toxic. You don't want to touch, except you're one of these brave guys that are designated to handle these messages. You don't want to touch these raw messages. So the message, on the real message we can't train. We can't train on the tokens. They are still real messages. We can't use the dictionary because if we take the vectorized training data with the dictionary, we can get to the clear text message again. this is how classification works. We have the classification service. It gets a message from the customer, and it classifies it and says to the agent, hey, this is important to you, or this is not important to you. And to train and deploy that classification service, we have basically 3 steps. The first step is the toxic one, the preparation step. It's done really by one guy, one designated guy, who fulfills all the requirements to do this. And the output of this preparation step is a vectorized training data set, which we train on. It's an encrypted dictionary, which we transfer to classification, and of course a key to decrypt the dictionary, which we store in a secret store. And the key gets injected at runtime into the classification. And so with that, we can get from the labeled messages to a classification service that runs in production. And well, now we're at the point we know how to build networks. We know how to handle the data privacy and information security stuff. And now we have to ask ourselves where and how to deploy it. And we could have used something like TensorFlow serving for building and running our classification service. We decided against it because we are building microservices. Special interfaces, not so special, REST interfaces. And point is, we Dockerize every microservice. Every microservice, let it be a notification service, let it be a CRUD service, and the classification service is Dockerized. And we handle these, and we like these Dockerized services because they are immutable, self-contained images that we can stage through our continuous deployment pipeline. And it's nice for us because everyone in our team, even the ones that don't do deep learning, can deploy everything. That helps us. As I told you, the dictionary key is kept secret. It's in a secret store, and it's injected at runtime, so we can't use it and we can't get into it because the runtime environment is more or less really safe. And we use Docker, OpenShift, and Cloud Foundry to deploy our microservices. This is important because we have to look at our actual process. Even I won't go into detail, just to show you that it still holds that we've got 3 steps. It's like the preparation step, the build, train, and deploy step, and the production step. And you have to adjust for every environment you have in production. The point that you have to take, you think about where's my data flowing in, how to keep it secret, what kind of secret store do we use. Yeah. So basically I can say as a conclusion, deep learning works for us. We are in production, we are still running the service, we are trying to build other services with deep learning, like character recognition and reading and understanding of text. And it works for us only in an agile environment. This was a very quick, a little bit excited, so it was a little bit faster than I expected. It works only in an agile environment. Imagine doing this the first time in a big organization. You would normally write a concept. You would have this concept approved, then you would implement that concept, and then you go into production. It won't work because the first time you need to solve so many problems that you haven't seen when you've read the concept. And there's more to it than just finding the neural networks. You have to find the right neural networks. You have to achieve 80% accuracy. But then you have to solve lots of different challenges that are coming along the way. And one thing I haven't mentioned is how to train your developers, how to train your surrounding organization. This might be a whole session in its own. Like, how can we get someone into deep learning that has never been before doing stuff like this? And what really worked for us is, or was, or still is, thinking big, thinking of the washing machine, thinking of the personal assistant, starting small, acquire a gaming machine, choose an MVP, and be scalable once it comes into production, be scalable with the process you have. So thank you very much, and happy deep learning.